So after proving different properties of parallel lines that are cut by transversal lines, we will now move forward into solving problems involving parallel lines and transversals. Okay, so this is probably one of the easiest parts of our lesson. Okay, because this has already been discussed when we were in the 7th grade. Okay, but let's try to do a quick review on what we know. Okay. And also, let's try to use some of the properties and the theorems that we've discovered, like the alternate interior and exterior angles are congruent, those pairs of angles are congruent, so on and so forth. So let's try here on problem number 1. Okay, so problem number 1, given that lines C and A are parallel, find the value of variable A. So it can be clearly seen here that we have two parallel lines, line C and line A, and they have these two angles, 38 degrees and 3a plus 7 degrees. And we all know that those two angles are alternate interior angles. So therefore we have 3a plus 7 is equal to 38. From here we can now solve for the value of a. So 3a is equal to 38 minus 7. Therefore, 3a is equal to 31. And lastly, okay, we have the value of a. A is equal to 31 over 3. So very simple. So we have these two angles that are alternate interior angles, and they are congruent, and therefore they have the same measurement. And after solving for the value of a, we've determined that its value is 31 over 3. Okay, so for the second problem, we have again two parallel lines. We have line G, line G and line H, so they're both parallel lines, and they have a transversal. It's been cut by a transversal at 2 points, so that's transversal R. And for this problem, we want to know the value of B. Okay, so we want to solve for the value of B. So again, how do we solve for the value of B? So we have 2B minus 8 here. That's our first angle, and then we have a second angle, so that's 82 degrees. So to solve for the value of B, we just simply equate those two because they are alternate interior angles. Those are the type of angle, that's the type of angle that they have, or the relationship. So now we can solve for the value of B, so that's going to be 2B minus 8 is equal to 82, so they are alternate interior angles. And from here we can solve the value of B, so that's going to be 2B is equal to 82 plus 8, and this will give you 2b is equal to 90, and therefore the value of b is simply going to be 45. Okay, very simple. Okay, so for this third problem, we have here again two parallel lines. We have line B and line S. Okay, line B and line S, and it's been cut by a transversal, line H, and we want to know the value of C. Okay, so how do we know the value of C? How can we get the value of C? So the first thing that we notice here is that we have a 93-degree angle here. Okay, so there's a 93-degree angle, and what the relationship that we want, essentially the relationship that we want to find between these two angles, we want to get the measurement of this angle. Okay, because if we get the measurement of this angle, then we get the measurement of angle C, for C plus 1 degrees. Okay, so that angle, because that's the those two angles are alternate interior angles. Okay, so we can try to equate these two angles, but we still need to find this value. Okay, so how do we find the value of this angle, the one that's adjacent to 93 degrees? So since this is a line, that's a straight line. Okay, so since that's a straight line, we can essentially get the value of this angle by equating it to 180 degrees, since the measurement of a line is 180 degrees. So this is going to be 180. Okay, so let's call this angle X. Okay, let's try to call this angle, the one that's adjacent to 90 degree is X. Okay, so 180, okay, minus 93 degrees. Okay, so 180 minus 93 degrees is equal to X. Okay, and okay, so what's 180 minus 93? So that's essentially x is equal to 87. And from here, we can substitute this value, okay, to the value, we can equate this value, we can equate this value of x equal to 87 to 4c plus 1, since they are alternate interior angles and they are congruent. Okay, so we can write here as 4c plus 1 is equal to angle x. And we all know that angle x is equal to 87 degrees. And from here, we can now solve for the value of c, the one that we want, the variable that we want to solve. So this will give you 4c is equal to 87 minus 1. Okay, and lastly, this will give you 4c is equal to 86. And therefore, okay, therefore the value of our c, of the variable c, is equal to 43 over 2. Okay, 43 over 2, or 21 over 5. Okay, so the value of c is 43 over 2, or 21.5. Okay, 21.50. Okay, so that easy. Okay, so let's try the fourth problem. Okay, so we have here an angle. Okay, we have here actually 4 lines. We have here 2 parallel lines. The 2 parallel lines that we have is angle B and angle Y. And we also have another line here that's not parallel to any line on the given figure, so it's line F. And also we have here this transversal. So let's name this transversal as letter L. Okay, so given here that we have here 127 degrees, okay, so we want to know the value of D again. So to solve, guys, okay, to solve for the value of D, the first thing that we can do here is we can try to find the measurement of this angle right here. Okay, so this angle right here is actually, if you look closely, it's actually the alternate interior angle of 4D minus 9. Okay, and again, what are alternate interior angles? They are congruent, so we can equate these two angles right here. But we need to find its measurement first. So to solve for the measurement of this specific angle, so let's call this angle y. Okay, so to solve for the measurement of angle y, okay, angle y is equal to 180 degrees minus 127. So where did we get the 180 degrees? Again, these two angles, the two adjacent angles, 127 degrees and angle y, are lying on a straight line. So if they're lying on a straight line, then they have a measurement, the total measurement, if you add them together, you get 180 degrees. Okay, so to get the measurement of angle y, we just simply minus that, the given value here. So we have 180 minus 127, we get 53 degrees, okay? So that means the measurement of angle y is equal to 53 degrees. And from here, we can see 4D minus 9. Okay, so there's this angle, 4D minus 9. And again, what are angle y and 4D minus 9 angles or degrees? Okay, so they are alternate interior angles, and therefore, we can equate them because they are congruent. Okay, so this will become, okay, so this will give you angle y. The angle y is equal to 4D minus 9 degrees. Okay, and we all know that the value of angle y is 53. Okay, so you write that here. So 53 is equal to 4D minus 9. Okay, from here we can solve the value of d. Okay, so we can transpose or use the addition property of equality. So this will give you 53 plus 9 is equal to 4D. Okay, and 53 plus 9 is essentially 64. Oh no, 62. Okay, so let's try to check that. 53 plus 9, okay, so that's 62. 62 is equal to 4D. And what's 4? Okay, 62 divided by 4. Okay, and 4 divided by 4. So we get here D. And the value of 62 divided by 4 is 31 over 2. Okay, so there you go. So our answer here, okay, the value of D, okay, the value of D is equal to 31 over 2, or simply 15.5. Okay. Okay, so we have here our fifth problem. So we have here 1, 2, 3, 4 lines, and we have here line A and line R are parallel to each other. Okay, so those are two parallel lines, and we have here transversal to the two parallel lines, so it's line P. Okay, and we also have a line S here. So we want to find the value of F. Okay, so how do we solve? Okay, how do we solve for the value of F? Okay, so to do that, okay, so what we can do here again is, we can try to use the alternate interior angle theorem. Okay, so alternate interior angles are congruent to each other. Okay, so since we know that this angle is 9F, we can say that this specific angle here, okay, so let's try to name it, let's say it's angle Z. Okay, so angle C must be equal to 9F. Okay, so it must be equal to 9F minus 180. Okay, so essentially that's it, because we have here a 180 degree angle. Okay, and if we subtract 9F from 180, then we will get the measurement of angle C, or the angle adjacent to 9F, which is 9F minus 180. And from there, okay, since angle Z, okay, we can write that since we have the angle C and its alternate interior angle is 3F minus 4. Okay, therefore we can say that these two angles are congruent. Okay, and therefore we can say that their measurements are congruent. Okay, and therefore we can equate that since angle Z through substitution property of equality is equal to 9F minus 180. Therefore we can equate that to 3F minus 4. From here we can solve for the value of F. Okay, so we put all of our variables on one side, so this is going to be 9F. 9F minus 3F is equal to 180, so this is positive, this is negative, and it's going to be positive on the other side. Okay, so this will give you 180, and then you have minus 4. Okay, so that's still minus 4, it retains its minus sign or negative sign. Okay, so 9F minus 3F, that will give you 6F. Okay, so that's equal to 180 minus 4, which is equal to 176. Is that right? 180 minus 4 is equal to 176. And from here, we can divide both terms by 6, okay? And therefore, the value of F, okay? The value of F must be equal to 88 over 3. Okay, so there you go. That's the value of F right here. Okay, and lastly, for solving problems involving parallel lines and transversals, we have the sixth problem. So we have here two parallel lines. Again, we have line L and line N, and it's two parallel lines, line L and line N, and we want to solve for the value of G. Okay, so that's the variable that we want to solve. Okay, so what's the value of G? Okay, so if you look closely here, guys, we have 3G plus 30, the angle at the bottom, okay, the third angle there at the bottom. So we have your quantity 3G plus 30 degrees. So what's its vertical angle? Okay, so we have here, this is the angle, this is 3G plus 30. So its vertical angle must also be equal to 3G plus 30, essentially. Is that right? Okay, so essentially this must also be equal to 3G plus 30. Okay, and again, okay, so again, guys, we have here 3G plus 30, and what we have here are the pair of angles that we have here are same side interior angles. So how can we say that? So 7G plus 1 degrees and 3G plus 30 degrees both lie on one side. Okay, so they both lie on the left side of this transversal that we have here, transversal V. Okay, so therefore, when we add their measurements based from the theorem, the same side interior angle theorem, when we add two of those angles, we have a supplementary angle. We form a supplementary angle which equals to 180 degrees. Okay, so this will give you 7G plus 1. Okay, so 7G plus 1 plus 3G plus 30 is equal to 180 degrees. And from here, guys, we can now solve for the value of G. So this will give you 7G plus 3G, so it's going to be 10G. And 30 plus 1, that's going to give you 31, is equal to 180 degrees. And from here, we can move or transpose 31 to the other side, so that will give you 180 minus 31. And if we subtract that, so it's going to be 180 minus 31, so that will give you 149. Okay, so 10g is equal to 149. And from here, we can now solve for the value of g. So we have 10g is equal to 149 divided by 10 for both sides. Okay. So therefore, the value of your g is equal to 149 over 10, or simply 14.9. Okay, so that's the value of our g for this problem. Okay, so very easy. We just use the same side interior angle theorem, okay, to find that the relationship here is equal to the supplementary angles. Okay, the supplementary angles of both angles 3g plus 30 and 7g plus 1 degrees.